Hello and welcome to this video lecture for Chapter 7. Today we'll be talking about how to build your tables or establishing your table structures. So after we get done with this, you should come back and look at these topics and ask yourself what it is that you know about each of those topics. Do you have a good understanding of what these topics entail and what we're talking about and how to create tables and resolve conflicts with field names that you might have while you're creating those tables. So the first thing we're going to do is talk about some guidelines for creating table names. So the table names need to be unique. They need to be descriptive and meaningful to everybody in the organization that might be looking at this database of the tables. Make sure that each table clearly represents a different subject and only one subject. You don't have multiple subjects in that one table. The name of the table needs to be descriptive enough to be self-explanatory. So an example might be vehicle maintenance. You wouldn't want it just to be called maintenance, especially if you had different types of maintenance in the organization. Every time somebody was looking for the table for the type of maintenance they wanted, they'd have to open up every table until they found the data they were looking for. And that's just a waste of time. So that's the reason why you want to be descriptive enough to be self-explanatory. So to create those names, you want to make sure that they're not unambiguous and they really identify the subject of the table. If the name is vague and ambiguous, it usually implies that the table represents more than one subject, which is something you don't want to do. An example might be, the word dates. Well, dates, there's a lot of different types of dates. So like example here would be birth dates. Well, birth dates don't belong with the sales dates. And so you make sure you give it a descriptive name that everybody will know and understand what that means. You don't want to use the word miscellaneous as a table name because who knows what that data will contain at that point. Some other guidelines for creating table names is you want to use the minimum number of words necessary to convey what the subject of that table is. You want to avoid names that are too short, that really have no meaning, especially to someone who might get transferred into the company or transferred from a different division that doesn't know or wasn't part of creating that database. So if you see something like TD_1, nobody would have any idea what that means. You also want to avoid long names like multi-use vehicle maintenance equipment. While that's very descriptive, when you have to use it in your queries and type things out, it makes it very long and cumbersome to type out over and over again. So there's a mixture that's just right. Long enough to convey information, but not too long. You also don't want to use words that convey physical characteristics. Words like file, record, or table. You want to avoid using any acronyms or abbreviations. You also want to not use proper names or other words that will restrict the data that can be entered into the table. So an example might be Southwest Region employees. Well, that implies that only those employees that are in that area would be entered into that data. So that if somebody was outside of that area, they shouldn't be entered into that table. Which means that if they were, it'd be hard for somebody to find the data that they were looking for. You also want to avoid names that implicitly or explicitly identify that table as being more than one subject. So if it requires something like an and or an or, it may need to be two different tables. So sometimes it's good practice to use a plural form of the word for table names and then a singular form for the field names. So an example might be for tables, clients, products, locations, versus field names, client first name, product ID, street address. Notice here that these are not too long, but they convey enough information for the field names. But this is called camelback or humpback notation, where you combine uppercase and lowercase in your characters here, and makes it easier to read. Previously, in older databases, you wanted to avoid using a space because the space wasn't easily always picked up upon when you're writing your queries. And so now that doesn't seem to be as much a problem, but it's just a carryover in terms of design. So when you see field names, they typically won't have a space in there. And then, so if you use reports like we've done in Access, you don't want this to be displayed as your column heading in a report. You'd probably want to just have first space name, and that's where you would specify a caption on your output. But anyhow, back to designing tables and field names. It's good practice, plural for tables, singular for fields. So when coming up with a table and creating it, here are some elements of an ideal table. It should only represent a single subject, which can be an object or an event. It should have a primary key, but I've seen tables that don't. It does not contain multi-part or multi-valued fields. So a multi-part or multi-valued field would be something like, let's say I was keeping track of instructors and I wanted to know what classes they were teaching. Well, under the field class, I might have all of their classes separated by a comma. Well, that's a multi-part, multi-valued field, and you don't want anything like that because it makes it difficult to retrieve or find out who's teaching 200 level classes. Well, what happens if somebody didn't enter the 200 level classes first? You'd have to write some kind of search algorithm that broke down that multi-part field and then look for information in there, which is very cumbersome and time consuming. You also don't want to have calculated fields in there. That may be changing a little bit, but for the most part, you want to try and not do that. And what I mean by calculated field is, let's say you had an inventory database and you had one field that had quantity in it and another field that had price. So if you wanted to know the cost of your inventory for that particular item, you would just multiply quantity times price. Well, some people were creating another column called, inventory value and doing that. And so previously, when computers cost a lot and storage was very expensive, and it took some processing power to do that, especially when you had millions of records, to do a calculated field would take up a lot of time. And so you would just do the calculation on the output and print it, but you would never store it since you had the information to produce that result. All right, so then another ideal thing to have for a good table is it doesn't have unnecessary duplicated fields, and it contains only absolute minimum amount of redundant data. So redundant data, you see that when we have our links from a primary key to a foreign key. Well, that data is repeated in our database, but it's at a minimum. So the next thing, once we've got a good table name and well thought out, we need to start creating our field names. So here's some guidelines for field names. They're very similar to, creating the table name. That is, those field names need to be unique. They need to be descriptive enough to be meaningful to the entire organization. And the field name should only appear once in the entire database, unless it acts as a foreign key in another table. So you don't want to capture the same information in different tables, because then if something changes and you don't do the updates to one table or both tables, you've got inconsistent information. The next thing is create a name that accurately, clearly, and unambiguously identifies the characteristic that the field represents. So phone number is a little bit ambiguous in terms of you don't know if it's their home phone, a work phone, cell phone, or something else. And so you want to be a little bit more specific. You can make it more specific by making it more descriptive by adding an abbreviation that will identify the table. So example might be you have employee home address could be abbreviated something like EMP home address. So we know that it's part of the table employee. You also want to minimize the number of words that are needed to convey the meaning of the field. You also want to avoid acronyms and abbreviations. And if you're going to use them judiciously and consistently. That is, if you're going to have table name abbreviated in front of the field name, then make sure you do that in all your tables. You don't want to use words that would confuse the meaning of the field name. You also don't want to use names that implicitly or explicitly identify more than one characteristic for that field name. So something and something or something or something would mean a multi-part or multi-valued field. So another example would be phone or fax. So you might have that number listed there underneath the field name, but you wouldn't know whether it was the phone number or the fax number, and then you would be putting out incorrect information and people might be trying to call the fax number. Another guideline would be to use the singular form of the name. Remember, multiple plural forms were used for tables because they contain records that were similar to, are all alike or similar. All right. So next thing we want to talk about are elements of the ideal field. So keep in mind it represents a distinct characteristic of the subject of the table. To me, that's an attribute, so that's the current terminology. It should only contain a single value. You shouldn't be able to deconstruct it into smaller components. That is, it's not multi-valued. And an example that would be is, let's say you had a student ID number and someone thought that wouldn't it be good if we had the student ID number, the last 2 digits indicated what county they were from. Well, to do that means if somebody's looking for that information using that student number, they're going to have to do some different processing that's going to take a long time to do. And so you don't want to have a field name value that can be deconstructed into smaller parts. Since you're not capturing a mathematical formula, then you should not contain calculated or concatenated values. Concatenated values are values that are put together to form a larger value, or not a value, but a larger piece of data. So an example would be if you combine first name and last name together, then that would be a concatenated value. Now you could do that with numbers as well, but then you'd have to write some kind of script to extract that information back out if you wanted it separately. Another element of an ideal field, it should be unique within the entire database structure. That is, I shouldn't have the same field names populated in different tables. The last one here is that it should retain a majority of the properties when it appears in more than one table, if you're going to have to do that. And so that means if you're using it as a foreign key, it should be very similar to that primary key. It just means that as a foreign key, the value, the specific value, could be repeated. So if the student ID were used as a foreign key in another table, then your student ID or whoever's could show up more than once in that column. That's all that means. So what are some problems with having multi-part fields? So the problem is that if you have a field that has data that is multi-part, that is more than one piece of information is contained there, it's going to be hard to get the information back out. It also makes it difficult to sort or group the records in the table by the field's value, because if it contains multi-part, you don't know which part the person entered first. Or, if there's 3 parts or in one record, but there's 2 parts in another and 5 parts in another, how do you get it so it all sorts on a particular part? It's hard to do. The way you resolve that is that you have to treat each part as its own separate field. That becomes a problem later on, because what happens if most of your records only have 2 parts, but occasionally you have something that might have 5 or 6 parts? Well, you have to build your database for the largest number of parts, so that's 6 fields to represent that, and then you'll have a bunch of blanks or nulls in most of your records. So again, we can resolve that later on. You probably won't see it but we can do some normalization, break those down into further tables, and that's typically how it would be done. And so as you're building this, you'll see that when you're entering the data, whether something will be multi-part or not. But you shouldn't be afraid of splitting them out, or at least asking if the field is actually multi-part. Similar to multi-part is multi-valued fields, and you should avoid those as well. This happens when you potentially store 2 or more occurrences of the same value and has the same fundamental set of problems as a multi-part field. So again, you're probably, when you go through the normalization process, you're going to break those down into different tables using a primary key and foreign key to relate those. And that ends the discussion for Chapter 7. Please be sure to read your book and look at your notes that you've taken while watching this video.